So in this demo, we will going to watch that how to do practical hands-on programs and various demos on R that's we do in real about every day for practical data science work and jobs. So there are a few things that for generally for a data scientist that for that's being expected from a data scientist that should know basically. As a data scientist work, we need to work in real life, like a little bit on R programming language. We need to work on Python, we need to work on SQL, we need to work on few other statistical software like SAS, SPSS, etc. So in this demo, we'll see basically the basics of introduction to R. That's how to coding in R, how to do the basic programs in R, how to set the environments in R. So we will see how to set up development environment on R. Basically, we will do all the experiments on our Linux environment. Basically, we will using our data science virtual machine, a simple dedicated VM that will be used for data science work. And in that VM, in the Ubuntu desktop, we will have all the basic packages for ours to be installed with its proper development environment, and we would continue our basic programming from there itself. Then we would also see that we're going to watch how to install RBase. We will install and extract basic R packages along with we will install few recommended packages that's needed to build visualization, plotting purpose, like plyr, ggplot2, reshape2, etc. And we will see a demo, a hands-on demo on customer demographic analysis using RStudio along with visualization. Alright, so let's get started with the basic hands-on part using R scripts. So let me go back to, switch back to my VM, that's my data science VM, that's which I already prepared for it. And let's continue with a few basic commands and steps in order to install RBase, and then we would go ahead and install RStudio. So I'm switching over to our data scientist team, so they will be presenting the demo. Okay. Let's go ahead.
So at first we will install the RBase by using the command this command. Sudo apt-get install RBase r-base. Yes. So now we can install our studio by this website.
So we need to download first the R Studio from our packages website. So we just need to browse through this following link.
www.rstudio.com/products slash rstudio slash download slash. So now I can install RStudio for Linux
64-bit.
64-bit.
So we are going to install the latest R Studio, that's 0.99.483. And this version is applicable to install in Ubuntu or Debian edition from Ubuntu 12.04 onwards. And if you're using Debian, so from Debian 8 plus onwards version, we can use it, but we need to choose it according to the version of your basic architecture of your OS. Like 32-bit, you can install 32-bit package. If you're using 64-bit Linux, you just need to install 64-bit.
So click on it.
Save it. Save it.
The file. Okay.
So we have done our basic downloading part. Let's switch back to the package. So here is the a package of our studio for one we have just finished the downloading. Now next we will go ahead and install this one. Extract. So switch back to terminal.
To extract this file,
we need to go to downloads first.
Downloads. To extract this file, use this command sudo dpkg -i studio .99.483. The file name d64.debian package.
Okay, so I think we need to install first this following command, because our studio has a dependency, because since it's from CRAN, from third party, so we need to make sure that this following package is being installed.
JPEG 62.
Now we can go ahead and extract our studio. So our studio has been extracted. Now we can search it. Click on this canonical icon and just simply type R. If you type R, you'll be able to see R Studio there. So go ahead and launch it. You can pin it into the taskbar if you use it frequently for your regular data science work. Otherwise, you can just go ahead and start building up our programs.
So now install the 3 important packages of R. First of all, plyr. Next is that install the packages gg.to.
So we have done the installation of the package ggplot2. Okay, so let's go ahead with our
load the packages.
Data sets. So we need to load the data sets.
Load the packages.
So before that, we need to load these packages, what we have installed.
Library. ggplot2. Now we can choose directory, set ordinary choose directory, and give the path.
So we need to first extract this.
Extract this file. Extract here.
So this data set we will be getting from GitHub resources. So just show us from which resources we will be getting the data set from GitHub.
The link is win vector. ZMPDSWR.
So basically we need to go to this GitHub resource and we need to download the respective data set. So we can just click on download zip so that we will be getting all the necessary data sets that is needed to perform the analysis on R for this demo purpose. So let's switch back.
Now we can start by the class data.
This represents a customer data set that we are going to work, because we will be doing a customer demographic analysis by the different states of United States. And so we'll be working on the various states customer geographic data basis analysis, like customer age variation, salary variation, on those basic factors, right?
Yes.
So let's go ahead.
So choose directory and give the path. This is cast data. Cast data. Okay.
Now after that we can use getwd to get the data, to get the directory of R.
Now we can load the data. Now we can load the cast data by using this command. Cast data is equal to table. Here is a TSV file called castdata.tsv. Data equals to true R3 separation of 2 /10.
So since the data set is basically, it's a TSV format, the main data set that we are going to work right now in cast data. So it's a tab separated format. So we have, and the data already had a header. So that's the data. Headers are also tab separated, and basic separated between the data lines are tab separated. So we are using the following feature, that we need to read this entire data from TSV file as in a table format, and we will be able to see that there is a header is there present, and also the separators are also there. Can you show us the basic data, that how it looks like?
Yes.
So this is the basic data, that how it looks like, and so we can see that there are some headers are present in the data set, like cast ID, customer sex, is employed, income, marital status, health insurance is there or not, housing type, recent movement, and number of vehicles per customer, age of the customer, and state of residence. So based on these details, we are going to check the customer information, and we are going to do basically a customer demographic analysis based on various steps in the US. So let's go ahead and start work.
At first, we use the summary of customer. Next, we can show examples of invalid values and outliers. You can write summary cost data dollar income. So the minimum income, fast quantity, and
the median income, the mean of those income value, and the third quantity, and then the maximum value.
Same as summary, the age, cost data, dollar age. Now we can start plotting. So first of all, we can plot a histogram chart.
So we're going to plot a histogram of the customer demographic analysis. So we'll be seeing basically a visualization, and that would appear in the right hand side window of the RStudio Paint. So let's go ahead.
Load the package library ggplot. Next, ggplot of cost data. Class GUIM. This is histogram. X-axis equals to age. Histogram. AES X is equals to age. Width is 5, and fill with the color. One color, just fill with like red. we will produce a density plot. Library scales. Scales is a scales ggplot of cast data. This is density plot, so density x-axis equals to first of all AES, then x-axis equals to income plus scale x continuous labels equals to dollar. It's dollar.
So there is a brilliant visualization has came up that's to show us basically along to the x-axis, which denotes the customer income level, and y-axis that denotes basically the average source of details about the incomes. So for the various customers along the various states. So we would be able to see that the income level has been increased from $0 to $200. So it's just been getting increased to $200,000. That's the average income level. So that's the most highest peak that it has reached, between $0 to $200,000 per annum. And the rest of the income level has a little bit decreased so far. So this graph denotes basically the average density analysis of customer demographic data over the United States. That's we plotted using R and ggplots. So let's go ahead with the next visualization.
Next, we can produce a plot called log scale density plot. So ggplot of customer data GM density AES x-axis equals to income plus scale x log 10 scale x log 10 breaks is equal to C of 100 100 10,000 and 1 lakh. And label is equals to dollar.
So this is another line graph that represents basically, so it represents in the income level again in log scale analysis. So we can able to see that since it has been taken as a base of log 10 basis, the income status has been analyzed. So we have taken the basic levels that's along to the x-axis, all the bases like 100, 1000, 10,000 and 100,000. That's all these bases of income that has been taken in the base log scale of 10. And based on that, we have plotted where x-axis denotes the income level, like from $100 to $1,000 to $10,000 to $100,000 per year on average basis income per state, and y-axis basically denotes the density level analysis on that.
Next, we can create a bar chart that shows the distribution of categorical variables. Cast data. GUM. This is bar chart, so GUM underscore bar AES. Xaxis equals to now marital state. Marital dot stat, and fill with just one color like gray or blue. Can choose.
Brilliant. So this visualization shows basically the distribution of marital status of people over the states, along with the number of people. So we can see that the distributions of divorced or separated people, that's it's around more than 100 to 200 people. So more than 100, less than 200 people, and over the married people, that's more than 500 distributions in average count. Never married, that's are also more than 200 people, and for widowed, that's just near equal to less than equals to 100 people. That's being around in the very statistical calculation of the customer demographic state over the 50 states.
Next, we can produce a horizontal bar chart. Just plot cast data. Plus GUM underscore bar X-axis equals to states. State of residence RDS, and fill with rate. Plus sorry, GMR of AES and X-axis equals to state of residence, and fill with red color, plus the function could flip and theme so axis dot text dot y axis equals to element dot text size equals to rel of 0.8. try replot constant plus GEM yes Xaxis equals to states of residence and fill with red plus function could sleep.
Alright, so this visualization that's typically shows up the distribution of customers on the various states and along with their population distributions on the according to the various states. So we'd be able to see that this graph is right now in basically in the ascending format, so that we would be able to see that. The name of the states has been starting from W onwards. So we can see that over the most populated states this compared to all other states is California, where it has got its average count of customer distribution has just reached near 200, whereas the other topmost states like we are having here Michigan, we have we have the other states like New York, we have the other state distribution overpopulated like Pennsylvania, we have other states over distributed like Texas, etc. All right.
So next I will produce a bar chart with the sorted categories. So I can write state sums is equal to table cast data dollar state of residence state dot res state f is equals to as dot data dot frame of state sums. Next is that the column names function short is col names state f is equal to c of state of resident res that should be count. We can see the summary of state f.
Okay, so this graph shows basically this implementation that similarly the number of states versus the count, but it shows basically in ascending format, in descending format basically. So it starts with Alabama, Alaska, Arizona, Ontario, starts to California, and the rest of other 44 states. It shows the distribution.
Next, state f is equal to transform of state f comma state of residence is equal to reorder .off.res. There should be count. Reorder, sorry. Reorder. Next we can make the plot. ggplot of state f plus, this is a bar chart, a bar yes, x-axis equals to state of res, state of dot res, and y-axis should be count stat equals to identity, stat equals to identity, comma, fill with a color like purple, plus the code flip function plus theme equals to Xaxis dot text dot y equals to element dot text element underscore text size equals to Arial of 8.
So this is basically going to be a plot, and we are using ggplot.
And this is the plot.
This is just we are using a different color, but we have again gone through in ascending format, and we can change it a bit. All right.
So next we can produce a line plot. So for this plot, write this command: x equals to run 100, y equals to.
So we need to basically initialize these variables, and on the basis of initializations, and we need to make all the statistical calculations over so far. And on the basis of statistical calculation, we could be able to plot the graph using the library.
ggplot.
Yeah.
Dot frame function. is x equals to y, and x equals to x, and y equals to y. Same is x equals to x and y equals to y. As GM line chart, so this is line.
So it's basically a line graph which we can see right now, and along the x-axis we have plotted the x value that represents basically the customer text values. That denotes typically the statistics for identities and the coordination flip value. That's the x-axis denotes the state of residence, y-axis denotes the counter distribution, but we have plotted it against towards the element statistical value. So we have given it x as x equals to x and y equals to x, and we plotted it as a line graph.
Next, we can examine the correlation between age and income.
So we can make a typical correlation graph between age and the customer income value. So we can write the following function in R.
As it had 2 equals to subset function of cast data. Consider $1 and consider $age. And 0 and consider $age. So $age less than equals to 100 plus and age and income. So and cast data dollar income 0. XUR function consider to $age cast data to $income, because age and income we will examine. Income. Next, we can make a scatter plot of income versus age. So write this command in our console. Gplot cast data to AES of x-axis equals to age and y-axis should be income, because income versus age. Income plus GUM point function with a space, then plus while in of 0 as 2100 or 2 lakh 1 2 3 4 5. We can see this plot. X-axis equals to age and y-axis equals to income, and age wise in 20 age the income equals to less than 50,000 and thus the income should be high. Like in age of 60, the income rate equals to 1,50,000 more than.
So we can see this is a scatter plot, and it's a brilliant graph that shows that it's basically in x-axis we can see the age distribution, and along to the y-axis we can see the income distribution. So along the age of 20, that's income starts from 0 to and just begin getting increases, and between 20 to 40 years of age of customers we can see the income level, it's mostly is general is average distributed more than 50,000 to $1 million and our annual income, and whereas more than 1 million to 1,050,000, it's also it's been getting increases. That's from 100,000 to 150,000. That's been but it's a little bit, but more or less distribution is show. We can see that from the age 20 just getting started, so between 20 and 30 income rate is getting increases, and 40 and 60 income rate is also quite high, and towards 60 to 80 income rate is quite linear towards the annual income rate of 50,000, but it's getting lesser towards 50 to $100,000, and beyond 80 it's just getting decreases.
Next, we can produce a Higgs-Beam plot. So for this plot, we can load the Higgs-Beam library. Higgs-Beam is a system library. Higgs-Beam or either library of Higgs-Beam so Higgs-Beam is a not valid library, so we can install it. Install dot packages Higgs-Beam. Go ahead and install. So now load the Higgs-Beam. So library of Higgs-Beam package. Higgs-Beam. Oh, sorry, library of Higgs-Beam. Next, with plot function, const data to AEX equals to AS of x equals to x-axis equals to age and y-axis equals to income. Age and y equals to income. In this example, Higgs-Beam plot. And GEOM of hex function, Higgs-Beam. So HEX, hex beam width equals to C of 5 and 10,000. Smooth function, smooth, and the fill equals to color equals to just one color like pink. Index equals to f female plus volume 0 volume 0 and and 2000 200,000. Next we can see this plot, the hexbin plot. The hexbin plot is this.
Wow, that's a brilliant plot. And it also shows basically the age versus income distribution, but it's a quite different type of a dashboard, and the graph is a different type, so we have used a separate library for this.
Hexbin
So
library.
yeah,
Hexbin library.
Hexbin libraries. So we can also export these graphs in the different formats. So if we just go over the plots and you can click on export, we'll be able to see that right now in our studio we have got the option to save any of the plot either just as an image format or an PDF format. So if you want to save this particular plot as an image format, you can use it. Just click on save as image. You can also change the image type like as PNG, JPEG, TIFF, BMP, SVG or EPS as a preferred format like hue. You can also customize the width and height and maintain a specific aspect ratio. And you can optionally select give a specific file name, and you can choose your directory for saving this particular plot. So alternatively, you can also save the graph as a PDF format as well, and you can specify the PDF file, the orientation format options, and optional directory, and preview also you could be able to get. So there are the various options that's being available. So we have seen a very good demo, and after that we can also publish any of the specific plot just by clicking publish button. So you'll be able to see that there will be prompt would come up like install required packages, so that would help us to publish this plot. That would also require some updating the versions of the package, like make sure that whenever you are publishing your demos, you are publishing your graphs visualization, you are always using the updated packages like for niter, yaml, html tools, ca tools, btox, markdown. So one just to make sure that you just install those packages and then just go ahead and publish your plots. All right, so all the packages, necessary packages has been installed, and now we'll be able to see that it has got for publishing a few other packages which is necessary to update, like rcarl, r json.io, pki, packract, RStudio API, and rconnect.
Yes.
So these are the various options that we can do right now, that's being available right now in our R Studio package. And apart from plots, we could be able to see the packages as well. So let me close this window and let me switch back to the packages, that whatever the current packages has been available in the user library which we have installed till now in the environment, what are the system libraries that are available and that's been utilizing. So mostly for our normal day-to-day data science projects and work, we use the various libraries like ggplot2 for grammars of graphics. We use hexbean basically for hexagonal binding routines based plots. We use plyr. It's a very normal tools for splitting, applying and combination aggregation of data. And we use scales as a package which helps for functioning of basic visualization. So this is basically was an overall demo for installation of R on the Linux environment, where we just showed that how to use RBase, how to work with our basic R packages from CRAN and ggplot, and we have also seen that how to write basic R functions, how to set directory, how to set up environment on RStudio, and we have utilized a sample demo on customer data over the 50 steps, and we have plotted out various customer demographic analysis using the various R functions and using the various R packages. And we have built out a few types of visualizations like bar graph, line graph,
Scatter graph.
hexagonal graph, scatter graph, and at the last we have shown basically a hex bin plot. So that was a basic demo was on that, on data science with R scripts. I hope you enjoyed the demo, and in next demo probably we would bring out some more visualizations and hands-on side of how to access the R data with MySQL and other databases. I hope you enjoyed the demo. Thanks for watching.